Okay, in this video, we're going to focus on understanding percentages. Okay, let's start by just breaking down the word really quick. Per means out of, and cent, if you think about like a century or how many cents are in a dollar, 100. Okay, so percents just mean out of 100. So if we have something like 95%, that's 95 out of 100 if I want to write it as a fraction. Okay, or what if I wanted to write it as a decimal? Well, 0.95, because remember, this is the tenths place, this is the hundredths place. So 95 hundredths, 95 hundredths, 95%, which is 95 out of 100. Okay, so all of these are equivalent. Now, obviously, if I was going to write it as a fraction, we should always try to simplify our fractions. What's our common factor here? 5. Okay, so this becomes 20. This becomes 19. So 19 out of 20. There's a couple important percentages that it's good to know, like in our head, what the equivalent is, specifically as a fraction. It can make our life easier sometimes. So those ones that we should really know, okay, would be 25%. That's 25 out of 100, or 25 hundredths. But again, we can simplify this, divide both the numerator and the denominator by 25. So it simplifies to 1/4. Okay, so 25%, 1/4, right? 25 cents, 1/4. Okay, 50% is 50 out of 100, or 1/2, right? We divide by 50. Okay, 0.5, or just 0.5. But I'll put the 0 here in the hundredths place just to make it clear. And then 75%, right? It's good to have in mind. Okay, 75 out of 100. Well, we divide by 25. This goes 3 times, 4 times. So 3/4. Okay, or 75 hundredths. All right, so now we're going to take a look at a type of problem we might see on the GED that involves percentages. So what is 25% of 80? So anytime we're trying to find a percentage of a number, right, one way to think about it is as multiplication. So I'm going to do 25% times 80. I could think about this a couple ways. I could think about it as 0.25 times 80. I could do that out. Or remember those fraction equivalents that we talked about. I could think of this as 1/4 times 80 over 1. Where did that 1/4 come from? Remember that 25 over 100, right? I can simplify to 1/4. Okay, the 25 out of 100, 25%. So this is probably actually the easier way to do it, because then again, if I can cross cancel here. This becomes a 1, this becomes 20. So we get right to my answer of 20. What is 25% of 80? 20. Okay. We can also use proportions to solve these, and sometimes it's a little bit more work, but what's nice about the proportion method is it works for every single type of percent problem we might see. So let's take a look at that. What is 25% of 80? Okay. When we use proportions to solve percent problems, we're always going to think of like the percent is going to give us 1/2 of our proportion. So 25%, boom, right there, that's half of our proportion that we need, because 25% is 25 out of 100. Okay, this represents the part, this represents the whole, right? The smaller amount, the total amount. So now in this other fraction on the other side, I just need to think about, okay, this 80, is the 80 like the 25%, or is the 80 the whole amount? Right? In this situation, the 80 is the full amount. So it should be in the denominator here, just like the 100, right? What I'm looking for is the 25%, right? What is 25%? That's the thing I don't know. So that's where I'm going to put x. Again, that value that I don't know. From here, cross multiply. 100x equals, well, 25 times 8 is 200. So add a 0, 2,000. Okay? And then what's our next step with proportions? Divide by the coefficient on both sides. Divide by 100. divided by 100. So I can just cross off these two zeros. And again, notice we still get our same answer of 20. What is 25% of 80? 20. So we're going to take a look at a few more to really flush out all the different wrinkles and different scenarios that we can come across. Okay, so let's take a look at another problem here. 50 is what percent of 120? So a couple different ways we can solve this. The first way we can do it is using proportions. So remember, our percent is always going to be 1/2 of our proportion. So if we have what percent, well, percent is out of 100. And when I don't know what percent, that's where I put x. Okay, and then on the other side, 50 is what percent? So notice that it's telling us the 50 and the x should be matched up in the numerator. Okay, and then the 120 is like the full 100%. Okay, from here, we can just cross multiply. 120x equals 5,000. Okay, and then our second step after that would be to divide both sides by the coefficient of x. And we get 5,000 divided by 120. 41.67, which is 41 2/3. So 41.67%, right? That would be our answer, 41.67%. The other way that we could do it, if we're strictly just asking, well, what percent is one number of another, right? I can just divide. I could just do 50 divided by 120, and I would get 0.416666, okay? Now, this here gives us a decimal. We need to then convert it into a percent. What's the relationship between 50% is 0.50. So if I'm going from the decimal to the percent, where's the decimal point right here? So I need to move it 2 spots over if I want to make it a percent. So 2 spots over would give me 41.67%. Okay, the same answer either way. Okay, so next problem we have to look at is 40% of what number is 72? So we're going to go ahead and solve this using proportions. 40% already gives me 1/2 my proportion because that's 40 out of 100. If I want to make my life a little easier, I could simplify that when I can, right? So now when I cross multiply, my numbers won't be so large. Okay, now all that's left is we have to decide, where does this 72 go? Okay, is the 72 like the 40, or is the 72 like the 100? Is it like the 40%, or is it like the whole amount? So 40% of what number is 72? So they're saying that the 40%, 72 is the 40%. So 72 needs to go up here in the numerator. And then the whole amount, right? I don't know. I put x. So from here, let's cross multiply. 4 times x is 4x. 72 times 10, 720. Last step. Divide by 4, divide by 4. Again, we could use a calculator, but let's just skip count up as practice. So if we start here at 0, where can I jump to? I can jump to 400, because 4 times 100 gets me 400. How much am I still missing? 320, right? We're missing 320. Well, 4 times 8 is 32, so 4 times 80. Altogether, 180. Okay, so 40% of 180 would give me 72. Okay, so let's imagine you need a 70% to pass a test. If there are 50 problems on that test, how many can you get wrong and still pass? We're actually going to look at 2 different very related ways that we could solve this. Okay, so you need a 70% to pass. First thing we do is, okay, well, how many questions do I need to get right? Right? If I know I need 70% to pass, I could say, all right, well, let's just figure out how many questions I need to get right out of 50. And then we could take it from there. I'm sure we can answer the question. So I could say, well, 70 out of 100 is equal to Okay, does this 50 represent the 100% or the 70%? If that's the total number of questions, so 50, and here I'd put X. Let's go ahead and make our life a little easier. Cross off a 0. We get 10x equals 350. We divide by our coefficient, and we get x is 35. So what this tells us is we need 35 questions right, which means how many can we get wrong? 15, right? We want to pay attention to what the question is actually asking us, and realize that here what we were solving for was how many do we need to get right. But this question asks how many can you get wrong? All right, so if we need 35 right, well then we have 15 that we could throw away, that we could get wrong. Okay, we could also set up a proportion such that we solve for the number that we're allowed to get wrong right away. And the way we do that is to remember that percentages pretty much always add up to 100, right? So if I need 70% right, well, here's my 100. I could break it into a 70 and a 30. So if I need 70% right, that means I can get 30% wrong. So I could, instead of using the 70% of my proportion, I could use the 30%. So I know I can get 30% of my questions wrong. So if there's 50 questions, well, how many can I get wrong, right? And now when I set up this proportion, I'll solve right away for how many questions can I get wrong. And I won't have to do this extra subtraction step, okay? Simplify our fraction, make our life easier. 10x equals 150. Divide by our coefficient. X equals 15, right? So we get the same answer either way, but I wanted to show you both approaches that we can take. So the last thing that we're going to take a look at when it comes to percentages is dealing with percent increase and percent decrease. Okay, so now, like I said, we're going to take a look at percent increase. So, you know, these are sort of accurate numbers, but I didn't actually check, okay? But we can imagine November of last year, gas was $3.10 national average. Okay, now the national average is $4.62. By what percent did you have gas prices gone up in this period? So the first thing that we need to figure out whenever we're doing a percent increase or percent decrease is what I'm going to call the raw change, right? That way it'll cover both increase and decrease. The raw change. So how much did it go up by? Well, I can actually do that by subtracting, right? Here's what it was now, here's what it is now, here's what it was. So I'm finding the difference, right? The raw change. So it went up by $1.52. So the raw change was $1.52. Now, if I want to figure out what percent increase that represents, I need to compare it to my original amount. Which one's my original amount? This one, right? Where we started. So I'll say, all right, 152 out of 310, okay? We could set up a proportion, but honestly, in this case, if they're asking us to do a problem like this, we'll definitely have a calculator. The easiest thing to do would be to pull out your calculator and just do 1 52/100 divided by 3 1/10, and you get 0.4903. Let's go to 4 decimal places, and we'll see why in a second. Okay, so what percent does this represent? Well, move our decimal 2 spots over, 49.03%. Okay, so this represents a roughly 49% increase in price. Again, to go from a decimal to a percent, we're going to move our decimal 2 spots over. Okay, so let's imagine that things just really go crazy. Okay, so we're going to keep our original baseline for gas at $3, but let's imagine that instead of it now being like $4.50, what if it was $8, right? What percent increase does this represent, going from $3 to $8? Well, we still need to first think about the raw change, right? How much did it go up by? What was the difference? 8 minus 3 is 5, so it increased by 5. We're going to compare that to the original amount, 5, and we're going to compare it to what it was, which is 3. Okay, now what percent, right? I'll show it how we could do this as a proportion. Okay, here's my change compared to my original amount. What percent does that represent? 3x equals 500. We divide both sides by the coefficient. 500 divided by 3. We get 166.67. Now, when we solve it using a proportion, because we already made it out of 100, right? This is 166.67%. We don't need to adjust it. If we didn't want to use proportion, we could just say, okay, well, let's do 5, the raw change. Let's divide it by the original amount, and that would get us 1.6667. Okay, and then from here, we need to move our decimal 2 spots to change it into a percentage. Okay, so it's really about whatever method you're more comfortable with. But if we use when we solve it with a proportion here, we're basically already making it a percent by putting it over 100. So we don't need to move the decimal point in this situation. Okay, so now let's talk about percent decrease. So let's say you go to the store, there's a sweater, a jacket that's usually $80, and now it's on sale for $30. So what percent off are you getting? Okay, just like with percent increase, we first need to talk about the raw change. Well, how many dollars are we getting off, right? 80 minus 30 is 50. So I get a $50 off, right? My raw change is $50. So if I want to know what percent off, I'm going to take my raw change, 50, and compare it to the original price, which in this case was 80. Okay? Now, we've talked about 2 different ways we could do this. We could just do the division. We could do 50 divided by 80, and we get 0.625. And then we need to change this into a percent by moving our decimal 2 spots over, 62.5%. Or we can set up a proportion. 50 over 80 equals x over 100. We cross multiply. 500 equals 8x. We divide on both sides by 8. And we will get 62.5. Notice that when we use proportions to solve these percent increase and percent decrease problems, we don't need to move the decimal point, okay? But we can also oftentimes just divide as well. It's really, I wanted to show both methods. Okay, so let's imagine you're still at the store. You see something else. The original price was $60. They say 75% off. So that's a 75% decrease in the price, right? So the question now is, okay, well, how much are you gonna pay? There's a few ways that we could think about this. We could figure out what 75% of the price is, and then take that away, right? Because that represents how much we're getting off, okay? But if we're getting 75% off, then what percent are we paying? Right? Remember, 100% represents our whole, so that's like a 75 and a 25. So another way to think about this is we pay 25% of the price. So I could do 0.25 times 60, right? 25% of 60, or we could set up a proportion. 25 over 100 equals x over 60. Okay, we can even simplify this to 1/4. Cross multiply, 4x equals 60. Divide by 4, we get x equals 15. So you would pay $15. If we did, we would get the same thing if we did it out here. 0.25 times 60. Let's add a placeholder 0. 6 times 5 is 30. 6 times 2 is 12. Plus 3 is 15. then we need to move our decimal back 1, 2 spots. Okay, either way, we get $15. So again, in this situation, it was easier for us to immediately get to our answer, to realize that if we're getting 75% off, then we're paying 25% of the price. I could have also made this 75, right? I could have done 0.75 times 60, which would get me 45, and that's how much I'm getting off. And then I would need to subtract that from the 60 to figure out what price I'm paying, which again would still be 15. Okay, so let's look at one more example. Let's imagine we have a high school track athlete. Okay, they're running the 200 meter, and at the start of the season, they run it in 34 seconds. They set a goal for themselves that they want to reduce their time by 20%, right? So they want to decrease their time by 20%. So the question is, what should their target, how many seconds should be their target if they want to reduce their time by 20%? Well, if we're reducing by 20%, that leaves us at 80% of the total time. Just want to point that out. Let's go ahead. This is the last problem we're going to do, so we'll solve it both ways. Let's start by just figuring out, well, how many seconds would a 20% reduction be? Well, 20% or 20 out of 100 is x is how much out of 34? Well, 10x is 68, right? Divide by 10. 6.8. So you would need to reduce your time by 6.8 seconds from the starting point of 34 seconds. So 34 minus 6.8. Right, I need to line up my decimal points, line up my place values, the ones place. So the target should be 27.2 seconds. Notice that in this approach, right, we didn't initially solve for the target goal. We solved for the reduction. If we use 80% instead, then when we solve our proportion, we'll get right to our final answer. So let's take a look at that before we wrap up. So 80% or 80 out of 100 is x out of 34. Simplify to make our life easier. 10 times x is 10x equals 8 times 34. Well, we can do that in our head, right? 8 times 3 is 24. 8 times 30, 240. Plus 32, 272. Okay? Divide both sides by the coefficient. And we get 27.2. Once again, so notice that when we set it up this way, we say, well, if we had a 20% reduction, that would leave us at 80%. So if we use the 80%, we can solve immediately for the correct answer. We don't have to do this extra step, okay? But either way is totally acceptable. Thank you once again for watching. I hope this video was helpful, and I'll see you in the next one.